Out there in the critical obscurity of space, the James Webb Space Telescope has been researching the dark for replies about the universe. It's NASA's new eye above, and it has been discovering stunning pictures of stars, huge systems, and planets at any rate before long. Something surprising has been tracked down, something so enormous it could shake the very spines of all that we know. It has researchers scratching their heads and analyzing whether it could prompt the farthest restriction of everything. Join us as we investigate how the latest revelation of the James Webb Space Telescope could destroy the universe. When we investigate the edge of the universe, it is the visible early phase. The visible universe looks like a window through which we can research the tremendousness beyond. The discernible universe envelopes everything that we can at present recognize, measure, and explore using our telescopes in space. Tests it's an assortment of stars, universes, and heavenly bodies within our degree of understanding. At any rate, the discernible universe is just a little piece of the whole universe. Imagine it as a bit cut of an enormous, unfathomable pie that we're able to study and fathom, while the total size and condition of the universe at large remain a mystery. Researchers estimate the width of our conspicuous bubble to be around 93 billion light-year. A light-year measures the distance that light, the fastest thing in the universe, goes in 1 year, around 588 trillion miles, or 946 trillion km. So when we examine the expansiveness of the detectable universe being 93 billion light-years, we're examining a huge stretch around 13.8 billion years ago. The universe burst into existence in an unfathomably strong impact. This impact began what we call the Big Bang. Since that momentous birth, the universe hasn't simply been growing, it's been advancing rapidly in its extension. Baffling forces like the mysterious dark energy give off an impression of being driving the speed increase, pushing the limits of the universe farther and farther apart. As the universe extended, matter began to mix under the impact of gravity. This gravitational force joined particles, birthing dazzling planned stars, astronomical systems, and ultimately planets like our own dear Earth. Picture the universe passing by as these huge plans frame, progressing into the different and still maturing quarks we see scattered across the universe today. Regardless of its immense size, the universe is inconceivably empty. Assuming that we were to contract our entire nearby planet group to the size of a quarter, the closest star would still be about the length of 2 soccer fields away. This tremendousness grows just within our own Milky Way system, which is only one among billions in the observable universe, giving us a sense of the sheer size of limitless space. Now you might inquire as to why we can't just see all that exists in the universe. There are a couple of explanations behind this limitation. Most critically, light, the fastest thing known to humankind, still takes time to travel through space. This means that when we look at distant objects, we're essentially examining the past. The farther an object is, the more its light has traveled to reach us. It's like looking through an unfathomable time machine, unrolling the history of our universe as we observe systems millions or even billions of light years away. The real universe is growing. Imagine dots on the surface of a blowing up balloon. As the balloon inflates, the dots move farther apart. The same rule applies to the universe. Galaxies like those dots are floating apart as the fabric of space expands. This expansion causes the light emitted from distant objects to undergo a shift known as redshift. Essentially, the frequency of light stretches as the objects move away, shifting toward longer frequencies, often seen as a bronze tone. Given these factors, light's travel time, the expansion of space, and the universe's continuous advancement, it's Not surprising that we haven't yet fully observed the entirety of the universe. Even with our highly advanced telescopes and technology, our view remains limited by these key properties of the universe. The journey to understand the possible edge or limits of the universe has enraptured the minds of countless individuals across disciplines, while convincing answers remain elusive. Three recognizable hypotheses have emerged, each presenting interesting perspectives on the vastness of cosmic space. The first hypothesis suggests that the universe grows unfathomably, continuing on endlessly without a noticeable edge. This idea aligns with the cosmological principle, affirming the isotropy of the universe is consistent in appearance from any vantage point. If this principle holds, it suggests that the universe has no boundary, expanding perpetually in all directions. The second hypothesis offers an alternative view, suggesting that while the universe may indeed be limited, it lacks a clear edge. Instead, it's like an epic circle or a curved space connected to itself, similar to Earth. In this scenario, if one were to travel endlessly in any direction, they would eventually return to their starting point, like circumnavigating the Earth. The third theory, the multiverse hypothesis, presents a fascinating idea. Our universe is simply one among countless others. Imagine endless parallel universes, each existing with its own set of physical laws, constants, and properties. These universes may be completely isolated from one another, operating independently, or they may be interconnected through complex systems, forming a vast and intricate multiverse. The James Webb Space Telescope, JWST, stands as a beacon of potential, illuminating the secrets that shroud the gigantic origins of the universe. This incredible instrument has an unmatched ability to disentangle the confusing past of our universe, allowing us to peer far beyond what was previously possible. The JWST is a mechanical marvel designed specifically to observe the universe with unprecedented accuracy. Its advanced capabilities extend our vision to the earliest moments of the universe. Recently, a groundbreaking study published in the prestigious journal Nature revealed the JWST discovery of 6 massive galaxies dating back between 500 million and 700 million years after the Big Bang. Incredibly, these ancient galaxies are far larger than expected for their early existence, challenging prevailing ideas about the universe's development and growth in its infancy. What's truly surprising about these discoveries is the level of development of these ancient systems, defying conventional models. These celestial giants display a degree of complexity comparable to our 13-billion-year-old Milky Way. The sheer number of stars inside these massive behemoths surpasses comprehension, each boasting a total mass several times greater than our Sun. Strikingly, one of these galaxies may even have a mass up to 100 billion times that of our Sun, eclipsing the already gigantic size of our Milky Way. The JWST unparalleled ability to see the universe's hidden regions relies on its use of infrared light and invisible spectrum to the naked eye. This remarkable power allows the telescope to capture the faint emissions from ancient stars and galaxies, revealing enormous remnants that have endured for billions of years. Essentially, the JWST acts as a time machine, taking us back through the ages and offering a rare look into the universe as it appeared roughly 1.5 billion years ago. The ongoing discovery of massive galaxies, affectionately nicknamed universe breakers, has overturned our understanding. It's akin to rewriting history, a shocking twist that challenges many of the models we had laid out for early galaxies. Initially, we thought galaxies formed from humble beginnings, starting as small collections of stars and dust. They were believed to gradually grow, increasing in size and complexity over time. However, the universe breakers have shattered. These assumptions when the JWST data and its high-resolution images unveiled these titanic structures they appeared, seemingly out of nowhere, appending our previous understanding of cosmic evolution. Digging deeper, scientists used spectroscopic techniques to analyze light across different frequencies. This examination holds the key to unlocking crucial insights about these mysterious galaxies, including details such as their structure, size, and distance from Earth. It's like a vast detective story with light as the clue to uncovering the secrets of these enormous entities. The stunning revelations from the James Webb Space Telescope have propelled our understanding of the universe to extraordinary levels. This cutting-edge telescope, built by a global team of space scientists, has recently uncovered an amazing discovery: the identification of the oldest and most distant galaxies ever observed. These galaxies transport us back to when the universe was just a tiny fraction of its current age, existing only a short time after the Big Bang. The James Webb Space Telescope, out in the immense void of space, has been seeking answers about the universe. It's NASA's latest monumental instrument, capturing stunning images of stars, galaxies, and planets. Recently, it made a discovery so remarkable that it could change how we comprehend the very fabric of the universe, leaving researchers baffled and curious about its potential repercussions. When we examine the universe, we begin with the observable universe, a window into the immeasurability beyond. This observable universe encompasses everything we can currently connect with our telescopes and space probes, including stars, galaxies, and other celestial bodies. However, it's just a small part of the entire universe. Researchers estimate the width of our observable universe to be around 93 billion light-year. A light-year measures the distance light travels in 1 year, roughly 588 trillion miles, making the scale nearly boundless. About 13.8 billion years ago, the universe began with the Big Bang, an epic explosion that triggered the immense expansion. Since then, the universe has been growing and accelerating, driven by mysterious forces like dark energy. Matter began to coalesce under gravity, forming stars, galaxies, and eventually planets like Earth is caught us. Development shapes the universe's colossal size, allowing us to observe only a small part of its vastness. Despite its massive size, the universe is surprisingly empty. For example, if our entire solar system were the size of a quarter, the nearest star would still be about 2 soccer fields away. This void stretches through our Milky Way, one of billions of galaxies in the observable universe, underlining the incredible emptiness of space. The reasons we can't see everything in the universe stem from the limitations of light itself. Even with the fastest technology, we can only observe light that has reached us. The further away something is, the older the light we are seeing, offering us glimpses into the universe's distant past. This observation method means that space is continuously growing as we perceive it. Understanding the ultimate boundaries of the universe is still a puzzle for scientists. Several hypotheses suggest that the universe may be infinite, lacking a clear edge. Others proposed that it might fold upon itself like Earth's surface. Finally, the multiverse theory posits that our universe may be just one among many. These theories continue to spark debates among astronomers and physicists alike. The James Webb Space Telescope has opened new doors in our understanding of the cosmos. Its unprecedented ability to observe distant galaxies has led to groundbreaking findings, such as the discovery of massive ancient galaxies far earlier than previously thought. These galaxies challenge our understanding of cosmic evolution, revealing a universe much more complex than we imagined. The telescope's use of infrared light allows scientists peer into the past, offering insights into the formation of galaxies and stars, the discovery of these universe breakers, ancient galaxies, challenges existing theories, and invites further exploration into the universe's origins and future. Sure,